So again, we have a linear term here of sine 2 theta, sine theta. So therefore cosine 2 theta has three different versions. I'll write them all here. Cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. Since this is a linear term, the best of these three to choose to make this equation easy to deal with is 1 minus 2 sine squared theta. This is never a good idea because you now introduce two different functions, which is annoying. So since the linear term is sine, the best one to choose is this one here. So we have negative 1 minus 3 sine theta equals 1 minus 2 sine squared theta. I'm going to move this stuff over this way. So I'm going to do minus 1 plus 2 sine squared theta. So I get negative 2 minus 3 sine theta plus 2 sine squared theta equals 0. I'm going to rewrite the order, so I get sine squared theta minus 3 sine theta minus 2 equals 0. So this is, to factor it, it has to be 2 sine and sine. I want a negative 3, so this is going to be a negative 2, and this is going to be a plus 1. Is that what I want? Yep. So I set these two factors equal to 0. I get 2 sine theta equals negative 1, so sine theta equals negative a half, and I get the sine of theta is equal to 2. This is of no help because the range of sine is negative 1 to 1, which is outside of that, so therefore that's no help. Sine of theta equals negative a half at pi over 6, but we want the negative ones, so that would be 7 pi 6 and 11 pi 6. So again, we have a squared term and a linear term, so we want to change this squared term into the linear term. I know that tangent squared theta plus 1 equals secant squared theta. So that means secant, so you do this substitution right here. So I'm going to replace secant squared with tan squared plus 1. So I get tan squared theta plus 1 equals, that's a plus 2 tan theta equals 0. I'm going to rewrite the order, so I get tan squared theta plus 2 tan theta plus 1 equals 0. This is prime, so it's just going to be tan theta times tan theta. 1's not prime, but the only factors are 1 in itself. I need to get 2 in the middle, so this is plus and plus equals 0. So I really just need to set one of these equal to 0. So I get tan theta equals negative 1. So tangent equals 1 at pi over 4. I want the negative angles, which would be the second quadrant angle and the fourth quadrant angle. This equation gets kind of involved. The problem is that there's no substitution we can do because both of these are linear. All of our substitutions are either based on double angles or the Pythagorean identities. So the trick to solving some equations, and in this case, is going to be squaring both sides. So I could square it in its current form, but then I'd have a middle term that has sine and cosine in the middle, and I don't really like that. So I'm going to move this cosine over, So I'm going to get the square root of 3 sine theta equals 1 minus the cosine of theta. I'm now going to square both sides, so I like a different color. Squared. So this is the square root of 3 squared is just 3, and then sine squared theta equals 1, and then this would be minus 2 cosine theta plus cosine squared theta. So my linear term is the cosine of theta, so that means I'd like all my other terms to be squared as cosine as well. This is already cosine, so I need to change this one into cosine. So sine squared is 1 minus cosine squared theta equals 1 minus 2 cosine theta plus cosine squared theta. So I distribute that 3, I got 3 minus 3 cosine squared theta equals 1 minus 2 cosine theta plus cosine squared theta. I'm going to subtract 3 and add 3 cosine squared theta. That's a pretty sad looking 3 cosine squared. So I get 1 minus 3, which is negative 2. That's also negative 2 cosine theta. And I add those two, I get 4 cosine squared theta. So I'm going to, when I have a constant, I can get rid of a constant, never want to get rid of variables. Multiply this whole thing by a half. So I get, I'm just going to change the order too. So I get 2 cosine squared theta minus cosine theta minus 1 equals 0. 2 is prime, and cosine just times cosine is cosine. So I have to have that. 1's only factors are 1 in itself. So I need to have a negative in the middle, so that means that has to be minus and that has to be plus. So the cosine of theta is equal to 2 cosine of theta is equal to negative 1. So cosine theta equals negative a half, and that gives me theta is equal to pi over 3, but I want the negative ones, which is 2 pi thirds and 4 pi thirds. And here I get the cosine of theta equals 1, so that's when theta equals 0. So unfortunately, there's kind of a rule in math that when you square both sides in an equation, you sometimes introduce extraneous roots, which in this case I don't think all 3 of these work. So we have to check them. So let's first plug in 2 pi thirds, so I get radical 3, the sine of 2 pi thirds, plus the cosine of 2 pi thirds equals 1. Note that I'm plugging it back into the original equation, not into the squared equation. It's going to work here, it just may not work up here in the original. So radical 3, the sine of 2 pi thirds is radical 3 over 2, plus this is going to be negative a half. And the question is, does that equal 1? Usually you put the question mark over the equal sign. Square root of 3 over 1 times the square root of 3 is equal to 3 halves minus a half, which is equal to 1, so that's a check. So the next one is 4 pi thirds, so I get radical 3 times the sine of 4 pi thirds plus the cosine of 4 pi thirds, and does that equal 1? Radical 3 times the sine of 4 pi thirds is going to be negative radical 3 over 2 plus negative 1 half is equal to 1. I'm going to go with no. So that's negative 3 halves minus a half, which is not equal to 1. So therefore we want to cross out the 4 thirds. And finally we just want to check 0. I have red for some reason. So 0. We get the square root of 3 times the sine of 0. That's 0, not theta. Plus the cosine of 0 equals 1. This is the square root of 3 times 0 plus 1 equals 1. That was a question mark. That's true. So therefore our solutions are 2 pi thirds and 0.